Alright, welcome to a video on solving two-step equations using something called the undo method. So let's get started. And we're going to start by talking about socks and shoes, because that makes all the sense, right? Okay, there is a connection here to math, just hang with me here. So, to begin with, let's start by thinking about what you do in the morning when you put on your socks and shoes. What do you do first? Of course, you put on your socks first. Then, you put on your shoes. You kind of have to do it in that order, right? It's not going to make any sense if you're walking around with your shoes over your or your shoes underneath your socks, right? Okay. Now let's think about what happens in the afternoon or the evening when you come home and you take them off. What do you take off first? Yeah, when you take them off in the evening, you take off the shoes first. And then you take off the socks. Again, there's an important point here, I promise. So, the first thing we put on was our socks, but that's the second thing that we take off. And the second thing that we put on was our shoes. That's the first thing that we take off. So not only are we undoing the process of putting on socks and shoes, we're doing it in an opposite order from the way that we put them on. And that's the key idea that you need to understand for two-step equations. Okay, so let's see how that applies. Okay, so just like taking off your socks and your shoes, we need to solve a two-step equation in this process of undoing what was done in the reverse order. Let's do that again. So how does this relate to solving two-step equations? Just like taking off your socks and shoes, solving a two-step equation is the process of undoing what was done in the reverse order. So for example, here's a two-step equation. 3x plus 5 is equal to 17. Two things are happening to your variable, which is why this is called a two-step equation. And it's going to take us 2 steps to undo it. So first let's identify what's happening to the variable. And there are 2 things happening. So here's our variable x. And we need to figure out not only just what's happening to x, but in the order that it's happening. So when you want to think of the order, think order of operations. Right? So there's 2 things that were happening to the x. First, it's being multiplied by 3. Remember, if you see a 3x, that means 3 times x. And the other thing that's happening is you're adding 5. Which happens first? Well, according to the order of operations, where the multiplication would happen first. So where it says first here, I'm going to put times 3. The second thing is we added 5. Okay, we haven't actually done anything yet. All we're doing is we're identifying what's happening. So now let's undo what's happened in the reverse order, just like we would do with the socks and the shoes. We're going to undo multiplying by 3 and adding 5, but we have to flip them around in the order. Alright, so the first thing that happened, multiplying times 3, is the same thing that we're going to undo second. The second thing that happened, which was adding 5, is what we're going to undo first. Okay, so how do we undo adding 5? Well, that's where opposite operations come in, and we subtract 5. Okay, so you see, we do that one first. Now we undo multiplying by 3. How do we undo multiplying by 3? Well, we divide 3. Although we don't usually use the division symbol, we use fractions, because dividing by 3 is the same thing as a fraction with a 3 in the denominator. That's how you write it in algebra, though. So now, this is your process. So we know already that an equation is like a balance, and whatever we do to one side, we have to do to the other. So I'm going to do these steps, but I'm going to do them to both sides. So I'm going to start by subtracting 5 from both sides. And I do this first because I've determined that's what I have to do first. So we know adding 5 and subtracting 5 cancel each other out, so that's nothing. So all I'm left with is 3x is equal to 12. First step is done. Now I'm doing the second thing. I'm dividing by 3. But remember, we use the fraction bar as a division. So divide by 3, divide by 3. This gets rid of this. This undoes this, because that's just 1. And we get x is equal to 4. Let's try another example. So a shorthand for this is just I write first, second, first, second. And the first one is sort of what's happening. And the second one is undo. So the first thing that's happening to the x here is it's being multiplied times 2. The second thing is it's being subtracting 1. Okay, remember you have to go in the opposite order. So I'm going to start by doing the undo of subtracting 1, which is add 1. And the undo of multiplying by 2, which is divide by 2. So now I'm just going to do that. Add 1 to both sides. These cancel. 2x is equal to 18. Divide by 2 from both sides. X is equal to 9. We're done. So if you ever have to do two-step equation problems and you get confused about what you have to do and in what order, try this technique. I'll show you a couple more examples because it can get a little tricky. Okay, this one. First, second. First, second. We have x, take away 9, divided by 4. Now, order of operations says division before subtraction, but actually it's like there's parentheses here. So the first thing that's actually happening to the x is subtracting 9. And the second thing that's happening to it is we're dividing by 4. So to undo that in this order, we have to multiply by 4. Remember, start with this one, and then add 9. You can't add the 9 first, right? Because this 4 is in the way. So let's go ahead and do that. I'm going to multiply both sides by 4. And what happens is these 4's cancel. And we get x minus 9 equals negative 20. Step 1 is done. Then I'm going to add 9 to both sides. And negative 20 plus 9 is negative 11. And there's our answer. Okay, one more example. 5 minus 9x is equal to 41. This one's a little trickier because these two are not quite in the order you're used to seeing them. Okay, but you're still going to do the same process. We can use the commutative property to rearrange these. Now, if you're thinking, but I can't use the commutative property with subtraction. You can with addition if we change this to addition. Okay, so it can become 5 plus a negative 9x. Then if you want to, you can rearrange the negative 9x and the 5. Now, this step is optional, but it might help you to go through this process. So now we see the first thing we're doing is multiplying by a negative 9. So times a negative 9. The second thing we're doing is adding 5. So when we undo that in the reverse order, we're going to subtract 5. And then second, we're going to divide by a negative 9. Notice the sign didn't change of the negative 9 because I'm going to divide by what was multiplied. So I'm not going to change that. Alright, so I'm going to do that. I'm going to subtract 5. And I get 36, and I'm going to divide both sides by -9. And I get x is equal to -4. Alright, thank you for watching.